All right, so I think I'm recording. Let's take a look at our Skill 6A homework problems. Um, Here they're asking us to simplify the square root of 72. So recognize that an index of 2 is implied and that we want to break down 72 and find a pair of values. Whenever you have a pair, we'll pull it out. So the easiest way that students usually find to break down 72 is to create a factor tree. So we've got 2 times 36 is 72, and 36 is 6 times 6. Okay. Now, although that this is not a prime factors, we have found a pair. So this index of 2 is telling us to look for pairs, and we have a property of square roots that allows us that if you have the square root of a times b, you can take the square root of a and the square root of b separately, and this allows us to say that the square root of 72 is the square root of 36 times the square root of 2. See, we've got this 2. Well, the square root of 36, because that 36 has a pair of 6's, that's just 6. And this 2 is only a single factor of 2, so we can't simplify it any further. And here's our final answer for number 1. All right, let's take a look at number 2. In number 2, again, we see a radical, and the index for this radical, it's implied that the number is 2, even though it's not written there. The number is 2. So we want to break down 50, and we want to look for pairs of values that multiply. Um, so here we've got 2 times 25, and see the large, we found a perfect square here. 25 is 5 times 5. So again, by using that same property that we can split this multiplication up, we can look at 50 as the square root of 25 times the square root of 2. Now, we know that 25 has a pair, and that we can take the square root of 25 and say it's 5, and that our final answer is 5 times the square root of 2. Let's take a look at number 3. So be careful with number 3. You have this negative 8, and that negative 8 is really just going to come along for the ride for just a moment. We've got this negative 8. Now, we want to look and see if we can simplify this square root of 32. So when we come over here at 32, 32 is 2 times 16. 16 is a perfect square. So we know that we can break apart the square root of 32 and call it the square root of 16 times the square root of 2. So we've got negative 8 times, well, we know the square root of 16 is 4, and we can't do anything to simplify the square root of 2 because it's just a single factor. And we do know that negative 8 times a positive 4 is negative 32. So our final answer for number 3 is here. Let's take a look at number 4. So again, in this problem, we have a number on the outside here, just a multiplier, and we can't ignore it. We can't forget that negative 3. But I just think of it as coming along for the ride here in the beginning while I focus my attention on this radical. And although it is true that 100 is 2 times 50, and then 50 is 2 times 25, and you have found a pair, and you have a pair here. But a lot of times it'll be a shorter factor tree if you recognize that, hey, 10 times 10, because this produces a factor of 2, this produces a factor of 5, and 2 times 5 is 10. So if you're able to, when you're looking at the breakdown of our numbers, try to find the largest perfect square that divides this number. Think of this as being 10 times 10, and it'll be a quicker solution if instead of breaking it all the way down into prime numbers, look for the largest perfect square. But if you do continue to break it down, you're going to get the same answer, because you see that 100 has a pair of 2's and it has a pair of 5's. So when you take the square root of 100, you're taking the square root of 4 and the square root of 25, which we know to just be 2 times 5, which is 10. So even if you don't recognize the largest perfect square and you break it all the way down, you're still going to get the same answer. It just involves more steps. All right, so let's take a look at number 5. So again, we have a multiplier out here in front, and this time we have a variable that's underneath our radical here. So we can split that apart, because we know that multiplication, we can write it as the product of two separate radicals. And we can come over here with 20, and again, I can say that 20 is 2 times 10, or I can say that it's 4 times 5, and I have found very quickly here the perfect square, the largest perfect square that divides 20. So we know that the square root of 20 right here is the square root of 4 times the square root of 5. Now don't forget that you have these other multipliers, this 4 and the square root of x. So the square root of 4 we know is 2. And since we have these two that we can't simplify any further, they expect us to put that back together again and to put that back under the same radical. And 4 times 2 is 8. Because if we have two separate radicals and you're multiplying them together, you can put it underneath the same radical. It's just reading that same equation I had before in a different direction. Before I had it written that you have a times b and you can break apart a times b. Well, if you can break it apart, you can put it back together again. Here's our final answer for number 5. For number 6. Now, in this class, we're going to assume that these variables k are non-negative, 0 or positive, because when we see the square root of k squared, we want to be able to just write this as k, and technically, if k is allowed to be a negative number, we would want to take the absolute value of it to force it to be positive. The principal square root of a number is always non-negative. It's always 0 or positive. But it's going to be easier for us if we assume that k can never be negative, and then we don't have to worry about the absolute value symbols. It just creates a little bit of a harder problem sometimes when you have to consider the absolute values. So I'll remove that consideration for you. I'll make the problem easier for you that you don't have to worry about absolute value symbols. So when we do this, let's get back to this problem. We can split apart that multiplication, and we can look at the square root of 32 and the square root of k squared. Now, 32, we've seen already, I think, in the previous problem that that's 2 times 16, and that 16 is 4 times 4, and that we've got a pair. So we know that we can break apart this square root of 32 to the square root of 16 times the square root of 2. And here I'll just still write this as k squared. Now we can come in and try to simplify what we've got. We've got 4 here. And then the square root of 16, that's another factor of 4. I can't do anything with simplifying the square root of 2. I can simplify the square root of k squared, and it's just a k. I don't have to worry about the absolute value symbols because we're going to assume that these variables are non-negative, that they're 0 or positive. So now we can multiply in any order. Let's have the 4 times 4 is 16, and let's put that k in front of this radical, because when we write our final answer, if we write this k over here, our handwriting could be sloppy, and we don't know for sure whether whether you want me to have this k underneath the radical or outside of it. And it's quite often just to ensure that students read the problem correctly, they'll put that k as a multiplier, they'll put it out in front of the radical so that it's a clear understanding that it's not 2 times k underneath here. So this is my final answer. So when I look at number 7, this time this one's a little bit different than the others. Ooh, huh, I didn't know I could do that. In the other problems, the index on the radical was a 2, and we were looking for square roots. Well, here it's a 4th root. So the 3 is on the outside. It's just going to come along for the ride. I'm going to break apart the 128 and the variable. And for just a second, I'm going to focus my attention on this variable, on this number 128. So 128, when we're breaking it down this time, we're not looking for a pair of numbers, we're looking for 4 factors. So it probably is in this case that we're not going to see a perfect 4th root very likely just by inspection. We're going to have to break this down all the way to prime numbers. 128, half of that is 64. And now I do know that 64 is 8 times 8, but I've got to be careful. With an index of 4, I'm not looking for pairs anymore. So I'm going to keep breaking this down. So 8 is 2 times 4, and the 4 is 2 times 2. So my tree is really expanded here, but I notice that all I have is factors of 2. You just have to be careful that you count them up correctly. So what we've noticed is this 128 has 6 factors of 2, right? I've got 1, 2, no, 3, 6. No, it has 7. Huh. 7 factors of 2. See, I said make sure you catch them all, and I didn't catch them all. If I count how many I have circled here, I've got a total of 7. Well, 7 is not divisible by 4. So remember, we're looking for groups of 4. So now I personally divide it. I sit here and say that 7 divided by 4 has remainder of 3. So I know that if I were to take the time to write out all 7 factors, that I'm going to have one group of 4, and I'm going to have 3 left over, 3 remaining. So when we simplify this, like I say, this one's a little more challenging. When you break down this 4th root of 128, what this factor tree is helping us recognize, if you have the 4th root of 128, that is the 4th root of 2 to the 4th power, which is 16, times 2 to the 3rd power, which is 8. Well, that I have enough here to simplify this radical and say that this guy is just, it's the ugliest looking 2 you've ever seen. This just represents the number 2. Now, the second factor, 2 cubed is 8, and we cannot simplify that. So let's come back to our problem over here. Don't forget that we've got a 3 right here. And what we just found out, that this 4th root of 128, we can replace it with 2 times the 4th root of 8. Okay. Now, what about, let's take a look at this 4th root of x to the 6th power. What does x to the 6th mean? Well, x to the 6th means that you're multiplying x together and that you've got 6 factors. But remember, we're looking for groups of 4. So we have one group of 4, but then we have 2 remaining. So again, I will do division. 4 goes into 6 one time with the remainder of 2. See that remaining 2? So I know that if you're taking the 4th root of x to the 6th power, you can break that down that you have one group of x, you have one group of 4 factors, and you have another group of 2 factors. Well, that's not enough to simplify. This is enough to say, hey, that's just the number x, because 4 divided by 4 is 1. That's just x to the 1st power. But I can't simplify this other one. I have to leave it like that. So what our scratch work over here has shown us, that this 4th root of x to the 6th is x times the 4th root of x squared. So now, since all of these are multiplication, we can change the order, and we want to group it together to make our final answer be more standard. So I've got 3 times 2, which I know is 6, times this x, so I have a 6x. Now remember that since this index is 4 and this index is 4, we can put the 8 times x squared underneath that same radical. And we know from our previous scratch work that we could not find a group of 4 for either one of these. For the 8, we had a group of 3, 2 times 2 times 2. We had, that was what was left over. That was our remainder in our division. So this is our final answer. And so this number 7 was a little more difficult than the other problems, but you have to focus your attention on this index, and that's the number you need in your grouping. All right, so let's take a look at number 8, and I'll bet you that it's not going to be a square root. It's going to be one of these higher order roots, most likely. I can't remember, so let's go look at it. Yeah, again, it's another 4th root. So the 8 is just going to come along for the ride. I'm not worried about this 8. And because this is multiplication, I can break this apart and I can focus my attention on 80 and then focus my attention on n raised to the 5th power. So let's come over and look at this 80 and let's break 80 down. So with a 0 there, a student's probably going to say, well, hey, 8 times 10. And then we know that 8 is 2 times 4, and 4 is 2 times 2. So we've got these prime numbers here, and we do have, look how many 2's we have. We have this 80, we have a group of 4. We have 2 to the 4th power. Now the 5, we've only got one of them. So if we come in to take the 4th root of 80, we know we can break this 80 down to 2 to the 4th and times 5. So this exponent of 4 is telling us we have a group of 4, and that's what we need to simplify that. So this first factor is just this base of 2. And we know that the 4th root of 80 is 2 times the 4th root of 5, because we didn't have a group of 4 here. We just had a single 5, and that's not going to simplify any further. So what our scratch work has helped us to do is to recognize how to rewrite this 4th root of 80. So remember, we have this 8 here that's coming along for the ride, and now now we're replacing the 4th root of 80 with 2 times the 4th root of 5. Now let's come over and look at this n to the 5th factor and see what we can do with it. It's bigger than my index, so I know I'm going to be able to simplify it. I have this n raised to the 5th power, which I know means that I have a total of 5 factors of n, but I'm looking for groups of 4 because that's what that index is, and I have some left over. So the 4th root of n to the 5th power, I can break it down and say, yes, I have a group of 4. I have one group of 4, but I have some left over that I'm not going to be able to simplify. So this 4th root of n to the 5th power, because this 4 divided by that 4 is 1, I just have one group of 4. I have n 1, 2, 3, 4. I have 4 factors there. And because this index is 4, that's what I'm counting, the groups of 4. So I have one group of 4, and I have some that were left over, so it doesn't simplify. So what that scratch work has done is helped us to rewrite this 4th root of n to the 5th. We know now that we can write it. We have a factor of n, and now we have this 4th root of n. So since all these are multiplication, we can multiply these in any order. So we want to take the 8 times the 2 times the n. Those are not underneath a radical. We want to multiply those together. So 8 times 2 is 16 times n. And then we take these two factors, and since they have the same index, this 4, I can put them underneath the same radical, and I have 5 times n, which is 5n, and there's my final answer. So I hope that helps, and I will talk to you later. Bye.